Let us get an overview of Spark SQL. Here are the standard operations which we typically perform as part of processing the data. In Spark, we can perform all the standard operations either by using data frame APIs or Spark SQL. As this section is part of the Spark SQL, we will primarily focus on Spark SQL in the subsequent topics and also the subsequent section. So when it comes to standard operations, they are primarily categorized into these 6 categories. One is selection or projection of the data using select clause. The other one is filtering the data using where clause. Then joining multiple datasets. Then aggregations. These are the functions that comes as part of the aggregations. Sorting the data, and then analytics functions. As part of this section, we will primarily focus on these categories. Analytics functions are a bit advanced, and there is a complete section for all the functions related to analytics functions. Now, when it comes to business requirements, select clause is typically used for applying standardization rules, masking the data, etc. So when it comes to applying the standardization rules, they are nothing but converting names and addresses to uppercase. Also, address might have street, city, state, zip code, and we might want to separate those things into different columns so that we can perform operations such as get the revenue by city, get the revenue by state, etc. Before getting into those aggregations, first we might have to apply certain row level transformations to split the address into these different fields. Also, as part of the selection or projection of the data, we typically mask partial data for compliance reasons. For example, with respect to SSN, we don't want to store the complete SSN number because of the compliance reasons, and hence we only store last 4 digits by masking the first 5 digits. It is the case even with the date of birth. Typically we mask date and month, and we only store the year. That being said, all these transformations are called as row level transformations because we are applying on individual rows by deriving new values from the existing column values. Then comes filtering the data. Examples for filtering the data are nothing but getting orders based on date. Date will be applied as part of the filter. Get orders based on product. Get orders based on category. So depending upon the problem statement, whatever columns that provide us the date or product or category will go to the where clause. Then comes joins. All the others are quite obvious from the business requirements, but join is more of a technical requirement than the business requirement. Once we get the business requirement, we have to evaluate against the tables, identify the tables from which data has to be sourced, and if you have more than one table from which we have to source the data to solve a business requirement, then we have to join those two tables. So joins are typically used when multiple tables are involved. Then comes aggregations. Examples for aggregations are nothing but get revenue for a given order. It is a total aggregation. Another classic example can be there can be a number of transactions for a given store. We might want to get total number of transactions or revenue generated by all the transactions for a given store. That is another example for total aggregation. Then get revenue for each order or for each store, where there will be a key such as order ID or store ID. Then we will be able to get the revenue for each and every order or store, or it can be daily revenue, which means revenue for each date. So the key will be date and revenue will be the amount of revenue generated from all the transactions that are done for a given date or for all the dates within the dataset. So typically if we say get revenue by date or get daily revenue for a 1 year of data, there will be 365 records. The first column will be typically order date, and the second column will be the revenue generated by all the transactions for that corresponding date. Like that, we'll have 364 dates and corresponding revenues for those 364 dates. Then comes sorting. Sorting is typically done on the final output. We might want to sort the final output by date. We might want to sort the final output by date, then by revenue in descending order. Typically, we'll have other attributes also in the dataset, such as store. So for a given date or for a group of dates, what are the top 5 stores? Or I might want to get the records in descending order by revenue, and I want to see date as well as store and then revenue generated. In that case, we typically sort the final output by date, then by revenue in descending order. Another classic example can be sort the final output by state or province, then by revenue in descending order. We might have other attributes such as store, so that we know what are the top performing stores and worst performing stores. Analytics functions are typically used for ranking and other functions that are available or other functionalities that are covered as part of the analytics functions. Couple of classic examples are nothing but get top 5 stores by revenue for each state. Also get top 5 products by revenue in each category. These are nothing but ranking type of business requirements. There can be other business requirements that can be solved using analytics functions. For now, I am just covering these things. When we actually get into the analytics functions module, we will get into a lot more examples to cover all the aspects with respect to analytics functions or windowing functions. So this is the brief overview about what all transformations that can be performed using Spark SQL. We'll be using Jupyter Hub to actually demonstrate the capabilities of Spark SQL. As part of the Jupyter Hub, we have a kernel called as Apache Tori Scala, which accepts percentage SQL magic command to run SQL queries. For that, I might have to start the Spark session using this simple Scala script. You should see the output like this. Make sure you copy paste this and you can run as part of your Jupyter Hub environment, which will be set up when you actually sign up for our labs. If you are not using our labs, you can either use Spark Shell or PySpark depending upon the programming language you want to explore, or you can also launch Spark SQL and you can take it further. That being said, as we understood what all transformations that can be performed as part of Spark SQL and also as part of the agenda for this section, we'll primarily focus on selection or projection, filtering, joins, aggregations, and sorting. Let's get into those aspects and then we will get into some advanced topics as we get into the subsequent sections.